Dream to become the next Sir Isaac Newton or Albert Einstein? Learn from the master. Refath Bari. Watch his videos to achieve your dream.
Hello, instructor.
Thank you. Welcome to Linear Algebra lecture number 37. Today we go even deeper into matrix elimination. You may or may not have recognized that for the last few lessons I've been giving you scaffolding, which means I've been giving you a lot of support along the way. Today I'm going to remove some of that scaffolding, see if you can still perform matrix elimination the same way. So let's go ahead and get started with a quick do now. Okay, here's the do now.
Another class a week ago.
Yes.
Another monthly class that scaffolding is important.
Not to me. I have my own philosophy. And part of my philosophy begins with assuming that the student is always wrong.
That is the complete opposite of Theorem Lunar's philosophy. Always assume that the student is right. Right? Do you follow his philosophy?
Yeah, and also PSA.
Yeah,
Also
but do you
Lab
follow Refath's philosophy?
No, I don't.
Instructor?
No.
Okay, folks.
Yeah.
So first and foremost, you will be asked to write the matrix. To write the system of linear equations in AB notation. So go ahead. Good luck, and thank you.
Blah. Easy peasy. 4, -3, 1, -8, 2, 1.
Negative
I always make
Negative
things
2.
seem easy.
Negative 2.
Oh, -2, yeah. 1.
We encourage all mistakes.
Wow, you love assuming the student is wrong,
All right.
right?
So are you?
Love wrong.
Whenever you're done, please head back to your seat.
He's the
Aye.
fatal mistake.
Why did you do that?
Yeah.
Instructor, change your answer. Correct answer to wrong answer.
Okay. So as always, I want to start by assuming that the student is wrong, and in this case the student is indeed wrong. Let's take a look at some of the mistakes they have made. First and foremost,
Oh wait,
all we need to do.
correct the mistake.
Okay, perfect. That's what we like to see, student correction in the classroom. Writing the AB form is as simple as writing down the coefficients. 4 minus 2, 1, you see that. Minus 3, 1, minus 1, you see that. And 1 minus 3, 2. 1 minus 3, 1 minus 3, 2.
You always assume that it's wrong.
Yeah, well, it was almost right. Minus 8, minus 4, and 3, and that's the last column. Okay, so that's very good. That's AB notation, and hopefully that was pretty easy. For some of you, maybe a bit challenging, but where the real meat of today's lecture comes in is in the lesson. Okay, so in today's
no lectures.
Yeah.
It's special.
so today's lesson is gonna begin
It's a
as
little different. Did you get a mild cold?
so as always.
Buddy, this isn't the time.
Today's lesson is going to begin with identifying what we want to do with this matrix. Remember, when you look at a matrix, what you should really see is not a matrix, but what should you see when you look at a matrix? You should be translating it.
Triangular form.
No, but even less abstract. A matrix is a very abstract form of what?
Linear equations.
Good, a system of linear equations. Okay, so when you look at a matrix, you should see the linear equations in your head. Okay, so let's go ahead.
Your philosophy master.
Yes.
Your philosophies are like 0 out of 10.
Okay, the first and foremost, what I'm going to do is write down our goals. It's always good to have a checklist whenever we're performing matrix elimination. Okay, and what I want you to do, especially today, is start adapting this checklist into your mind. A mental checklist for what you should do whenever you see a matrix and you have to perform elimination. And let's see, I'm gonna label this checklist my goals. Okay, first and foremost, about the goals. What is our first and foremost goal? Can you please inform us, Isaac?
It seems like Alex has returned
No, excuse me. Tell me what is my first and foremost goal, which I
Solve
said the
X, Y,
same.
Z.
Good. I have to solve for X, Y, Z. My second goal, I want Alex to tell me.
Right triangle.
Upper triangular form, yes. That's always what I want to achieve when I'm looking to eliminate the matrix. And now I want you to tell me what are the terms in this specific matrix that I have to eliminate.
F21, F31, F32.
Yeah, F21, F31, F32.
Okay, seems like it's getting too easy. I'll have to,
Up the talent?
yes. So which one is F31?
Last one.
This one?
No, 1.
Oh, good. Okay, so let's call it F31, F32, and F21, right? So, okay, so really in this lesson is all about reinforcement, right? So we seek to eliminate, and our third, fourth, and fifth steps will likely be the same. Eliminate.
God, you don't have to say eliminate 5 times.
And what do we want to eliminate? We want to eliminate F21 to 0.
God, how many times are you going to get your brain?
2 more times. We want to eliminate F31 to 0. And lastly, we want to eliminate F32 to 0, as Alex correctly stated. And last thing in today's lecture you will learn is something very important called P's and M's. You won't understand what that means until the end of the lecture. Hopefully that serves as a puzzle for all of you who are already bored. Now, let's go ahead, let's start with the first step. And what is the first step we should start with? Which one of the goals?
It's F21.
Eliminate F21, right? How can
Can I try to do that goal first?
One second. Before you begin that goal, let me just help you get started. Remember, whenever we, let me actually say to the class, whenever we, one second, Jesus.
Wait.
Okay. Whenever we,
Jesus Christ, you got answer.
whenever we want to eliminate a term, we have to start with the elimination matrix. Let's take a look and see if our student did that correctly. Okay, so immediately, I don't know the answer to this question, but immediately I see that the form is correct. How do I know that? Because this already looks like an identity matrix, okay? So you should keep that in mind. Like your elimination matrix should look like an identity
Put the
matrix.
good number in the good place?
So let's take a look.
Did you do it in the head?
Yeah. Okay. So we hope to eliminate F21, right? So the number, the multiplier in our elimination matrix should be in what spot? 21, right? E21, right? That's where our multiplier should be, and that's where our student put it. So that's so far so good. The location of the multiplier is good. It's perfect. Now we have to see if the multiplier itself is correct. Well, let's see. If I multiply my first row by half, Alex, would you like to tell me what I get?
1/4.
No, if I multiply, what does this half mean? What does this half tell me to do?
Multiply the first row by 1.5 and
Jesus.
add it to the second.
Yeah.
Right. Okay, Alex, would you like to do that?
So, I would like to do
Multiply the first row by half?
by half
Yeah.
1.
No.
Oh, multiply by half. Oh, okay. So 1/8.
That will give you 8.
No, multiply this by half.
Oh, okay.
Yeah.
0.5 times 4 is 8.
No, okay, let's go ahead. It's 2.
16, okay.
Jesus Christ. Half times minus 3 is?
-1.5.
Minus 3 halves. And half times 1 is?
5.
Half.
God.
Oh, okay.
I
Half.
still have 8. Half times minus 8 is?
Okay, half times minus 8 is -4.
Oh, thank you. Okay. And now we just have to add to to the second row, right?
Yeah.
Did
If
I write
Zero.
the identity matrix correctly?
Alex,
I think so.
Would you like to come up to the board and write?
Yeah.
Write.
I would like to, never mind.
No, we
Alex
must.
has spent a lot
We
of
must
time.
give the low achieving students an opportunity.
Yeah. Wait, they're discriminating against the low achieving students?
No.
Oh yeah, but you're calling everyone the low achieving
Oh,
student. I always assuming the people who are.
Centipede. Oh my God. There is a.
Huh?
There is a.
Oh, wow. Okay.
Is this a welfare?
Come on.
The heartless buck.
Okay, Alex. Whenever you're ready to give up.
Stop with the heartless bug. It's a scare of it.
So let's take a look at if Alex's answer is correct. Okay. So all Alex had to do is do the following. So let's take a look. Okay. So the first row should remain the same. Is it the same? 4 minus 3, 1 minus 8. 4 minus 3, 1 minus 8. Great job with the first row. It is correct. What about the second row? 2 minus 2, 0. Minus 3 halves plus 1. Minus half. Great. Half minus 3. Well, minus 3 is minus 6 over 2, right? So I should get minus 5 halves. And there you go. A fatal mistake. As expected. Wait, which one was I? Oh yeah, this one. So I said half plus minus 6 over 2 is going to give me
Negative 5.
negative 5 halves. And minus 4 is going to give me minus 8. And what about the last row?
1 negative 1, 2, 3.
The last row should actually be this one. 1 minus 1, 2, 3. Not
I
this
will
one.
do the elimination.
Because this is the row of the elimination matrix, not the row of the original matrix. So let's patch that up. And of course, if you ever get mixed up between which matrix you started with, just keep in mind that the elimination matrix is the matrix that looks more like the identity matrix. Okay, so have we accomplished any of our goals?
Yes,
Class?
so yeah.
Which one?
F21.
Perfect. Now, what I want you to do is the following. Can I erase this? Okay, so I'm going to erase this. Okay. Now, this is what I'm going to write on the board. Of course, I run up with markers, but okay. So now we have this matrix, and now tell me, class, what is my next step? What is the step I should do next in my checklist of goals? What is my next goal that I should do?
Oh, here, we said eliminate F31.
Okay, good.
Can I try to do that?
Now I want Alex to come up and write the elimination matrix for F31.
No, I believe I can do it.
No, you.
Do you
Okay,
think?
you can write the answer, but Alex will at least attempt.
Whoa!
Oh, okay. Alex has prematurely given up. Would you like to write the answer? Thank you.
Super inspired. 111. Always forget that. Then negative 1 4 0 0 0. Always start by assuming the student is wrong, so I'm probably wrong by your standards.
And as a matter of fact, I will begin by assuming he's wrong, but thankfully he's right this time. I hope.
This time I've been right the whole time.
Well, maybe not. So let's see. First thing we have to do is check if the multiplier is in the right place. What term do we want to eliminate, class?
F31.
F31. So what location should the multiplier be?
F31.
Is it in 31?
Yeah.
Yeah.
You want me to write it down?
Yeah, almost there. So the location is good. But now what we have to do is check if the multiplier itself is good. So minus 1/4 tells me to do what? Take the first row, multiply it by minus 1/4. So that'll be minus 1, minus 3/4. What else? Minus 1/4. And of course 2. So perhaps Alex would now like to write the new matrix after we multiply it by this elimination matrix. Oh, sorry. I should have.
It's okay. It's the same thing. Done.
Oh, thank you, Alex. And as usual, we begin by assuming that the student is wrong. Thankfully, my philosophy is indeed correct this time. Let's begin and take a look at
I
why.
think both scenarios.
First and foremost, Alex violated the basic rule of matrix visualization, which is we put a simple line to divide the right-hand B side and the coefficient matrix.
Yay.
So that is wrong. And what else is wrong? Let's take a look. Okay. First and foremost, the first row should be the same. 4 minus 3, 1 minus 8. 4 minus 3, 1 minus 8. First row looks the same.
The second row looks the same as well. I have a form.
Second row should also look the same because we're not eliminating anything from there. 0 minus half minus 5 halves minus 8. 0 minus half minus 5 halves minus 8. Second half looks great. Second row looks great. Let's take a look at the third row. So third row, remember, I'm adding it to the new first row. Minus 1 plus 1, 0. 3 halves minus 1, minus 1/4.
No,
3
3
halves
fourths.
plus
3 fourths.
Minus 1.
3
So it
fourths.
should be,
No,
Minus-
it's not.
Negative 1/4.
yeah, it should be negative 1/4. Likewise,
How? Isn't it minus? Oh no, it's
no,
plus.
it's plus, yeah.
Yeah, it's plus.
So those tiny like sign changes, try to keep them in mind. It's very easy to get mixed up. Minus 1/4 plus 2 is gonna be what? 7/4 as correctly written here. And 2 plus 3, 2 plus 3 is 5. So just little sign changes can result in big errors. So please try to keep a hold on that. But otherwise, has Alex completed another goal?
Yeah.
And what
So
is
we
that
have
goal?
to do F32. No.
31.
Yeah. So we've just accomplished goal 4. So now what we have to do is accomplish the final goal, which is eliminate F32.
Can
Okay.
can I try to do it?
1 second. So let's see. Now all we have to do is eliminate one more term, and of course that means we need one more elimination
Which
matrix.
I will do.
Okay, which our last remaining student will complete. 1 second, let me just write it out. Okay, so go ahead, write the elimination matrix, and good luck.
Okay.
This
one,
seems almost too fast,
um.
almost like you knew the answers,
What are you
because his
saying?
mind is like so fast.
What are you saying about me?
I think you're very high achieving.
You're thinking I'm looking. You think I'm sneaking a peek into your lesson notes?
No, because I have no lesson notes. This was completely improvised, folks. Anyway, let's take a look. Let's see if this is correct. How do we judge if an elimination matrix is correct? In two ways: location, multiplier. First of all, location. What are we trying to eliminate?
F32.
F32. Where should our multiplier be?
F32.
Is it in 32?
Yes.
Row 3, column 2. It's in F32. Location requirement satisfied. Now let's see if the multiplier is good. If I multiply my second row by minus half, let's see what I get. 0 times minus half, 0. Minus half times minus half, a 4. Minus half times minus 5 halves, 5/4.
So why we are multiplying in the second row? Why not the first row?
That is a good question. Well, I tend to think of a useful analogy, the analogy of a ladder, climbing down a ladder. Simply put, if you use the first row and multiply this multiplier by the first row, this is going to change the 0. So you will be basically reversing one of the goals you did before.
Okay.
So you basically backfire everything you spent trying to do for the last hour. But that's why we stick with the second row. Yeah, Gauss knew that. That's why he tried many times. He saw it. First row doesn't work, so he resorted to the second row. That's why we call this Gaussian elimination. So minus half times minus 5
Never knew
half.
I would become so as smart as Gauss.
Yeah, you are smarter than Gauss. You was smart, but you are
Not as
smarter.
smart as me.
No.
So let's keep that in mind, okay?
I bet you just stop some
Please
saying
stay
the
humble.
internet speeds.
Please stay humble. Okay,
Stay
perhaps
humble.
Alex
You're
will.
not being humble at all.
I don't need to be humble.
Oh my god!
I've won as many Nobel Prizes as possible. So Alex would like to write our
See it as you
resulting
were
matrix.
barely rich. Probably not.
The money is spent.
What, the money has been spent?
We have to change the F32?
Yeah.
What did you write over here? 5/4?
Yes. So thank you, Alex, for the contribution. Let's check if Alex is correct. Okay, so let's try to simplify when we can. 12/4. We can easily rewrite that as 3. So now let's take a look and check if Alex is correct. To check if Alex is correct, let's see if it all adds up. 0 plus 0, 0. 1/4 plus minus 1/4 is obviously 0. 5/4 plus 7/4, as Alex correctly stated, 3. 4 plus 5 is 9.
Right.
So that was a small mistake on Alex's part. But of course, these small mistakes happen because of small, things. Okay. Now we move on to the exit slip. Okay, and our exit slip today is extremely simple. And before we begin our exit slip class, did we accomplish any other goals?
Yeah, F32 is done.
And any other goals?
Yeah, the right triangle.
Yes.
Upper right triangle.
If you've been paying attention, you see that this is exactly the type of form we sought to establish, the upper right triangular form. And now, class, what is the only goal we have remaining?
XYZ.
Okay, so who would like to come up and solve for XYZ?
Me.
Well, thank you.
That's too easy for you.
Okay, so while he's solving for them, let me speak about the utility of linear algebra. So, linear algebra today is widely Linear algebra.
This isn't good.
Okay, you finished?
No, gotta find x. 4x plus.
So linear algebra is actually used to train artificial intelligence machines throughout the world, because they have to analyze images of sample sizes greater than 100, and these images are encoded in the form of matrices. So as a matter of fact, to train artificial intelligence, what you need to do is have a supercomputer that's very fast at doing all of this. So now let's take a look and see if our student has solved it correctly. He's solved that x is -2, y is 1, z is 3. And as a matter of fact, if we plug those numbers back in, so this matrix, it works, okay? So this isn't, as a matter of fact, the correct solution. And before I leave off today, there's one new thing in today's lesson, which is as follows. And this is, as a matter of fact, very important. See the terms lying along the diagonal? Class, do we know what to call these terms? We call them the pivots. Thank you for watching.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.